Hello, everybody. Good morning, good afternoon, good evening, depending on where you are. Welcome to Areopa. This is our 111th presentation. Tonight, we will be listening to Stefan Šošić, who will be giving us a talk about the cost of poorly written AL code and how that impacts SQL performance. So he'll be showing you your bad code patterns, the things that you're doing in VC, and we'll be looking at versions from 25, 26, and 27, and how the optimizer works and the SQL code that is created, and things you need to watch out for to make sure that you're telling VC to do the right thing so it's sending the right message to SQL. I'm your moderator, David Singleton, and we're in the middle of season 7. So just a quick housekeeping rules, which I think everyone knows. Your mic is muted. We have a question window. If you have any questions, please ask them in that window. My job is to pick up those questions. If the question needs an immediate answer, like if the sound is gone or it's something that's incorrect or that you feel is important, I'll interrupt Stefan. But for the majority of the issues, I will manage the questions, and we will have a Q&A session at the end of the presentation. So we have a lot of information now. This is becoming a huge library. And I know a lot of people will ask the question, you know, some of this stuff may look repeated. Almost everything is new. This is an environment which is great to get started and do presentations. But some sessions, like Stefan's today, are repeats that some of you may have seen at other places. But primarily, we do work on new data, new information here. Don't forget our Areopa YouTube page has a recording of every session. They're all there available. And obviously, subscribing to our email letter will get you that information. So if you got a screenshot, you can grab this, and you can get an email of every new sessions that are coming up. Just briefly, I won't hold this long, but we have every 2 weeks, as I think most people know, every 2 weeks we have a session coming up. And keep in mind, even though it's full schedule, we are still looking for other speakers, and especially the speciality of Areopa is first timers. If you really aren't ready to sit in front of an audience of 600 people and you want to you've got some information you'd like to share and warm up, this is a great environment to do it in. So obviously, big thanks to FORNAV, who are our sponsor, who provide us with the technology to create these presentations, to put it all together. And at this point, I am going to hand everything over to Stefan.
Hello, everybody. So let's start. So first of all, thank you everybody for joining this evening. So this will be the session about the performance in the AL and how some of the patterns behave, basically, whether they are good or bad, but what happens in the background itself. So we already can know that some patterns are bad, but we don't dig deeper, like in some cases, like why is like that. So in this webinar, we will go through exactly what happens in the database and explain why is the performance downside. So let me quickly introduce just myself. So my name is Stefan Šošić. For those who don't know me, you can follow me on LinkedIn, my blog page, and you can see me on GitHub, basically open source repositories for Microsoft mostly. So if you work there, we cross the path. So I'm also Microsoft MVP, focusing for basically Business Central technical part as main area. So yeah, that's quick brief of myself and the session. So now basically we can start first with the setup. So first what we need to cover is how are the tests performed here. So in this case we have the toolkit. So in Visual Studio Code. This toolkit is also available and can be downloaded with all scenarios, and you can test it yourself locally. But we execute the scenarios which are written here. We also used SQL Query Analyzer and SQL Server Profiler to catch all the queries which happen in the communication from the Business Central and Business Central database for each test. So we will be using separate sessions to run each test. All the tests are now pre-run just before this webinar, so we don't waste time on running or slow times. So also there will be no user caching, so we will just follow and analyze the pure performance of the SQL calls. On-prem and SaaS, basically the tests are validated on-prem, just so we can catch all the queries and see what's happening. But same behavior is on SaaS. Of course, the times how certain tests are run will differ on each machine separately. Even on the SaaS, if the SaaS environment is used more heavily, it will pull more resources into that environment and then have more executing power. So basically the times can differ, but the full logic and what happens behind will stay the same. So the bad pattern stays bad pattern, the good pattern is still good pattern, and we will see why. So for the tests, I've put here like BC25, the older version. I didn't test it, but why is like down version of the BC? So in the upcoming examples, we will cover examples which Business Central platform basically optimizes some of the SQL calls automatically, so without you optimizing your code. So even if you write like bad code, it can get good code at the end. So that behavior unfortunately doesn't exist on all older versions of Business Central. So just to be sure, I put it BC25 till BC27. So for this webinar, I used this BC27. And from the toolkit side, we will be using Business Central and have all the performance scenario demos here, which will be running. So the database is prepared with customers. In this case, we need to have one heavy table with, in this case, 1 million customers. And for the vendors, I made it like dynamically, so delete all vendors and create vendors 50. So in some cases, for some scenarios, we needed like small amount of records in the table. In some cases, we don't need any of the records in the table to analyze the SQLs which are communicated between Business Central and the SQL. So we've spoken about non-caching. So how we accomplish that. So before sending each of the calls to the SQL, we are doing database select latest version. And you can also find this on the Microsoft Learn documentation, even with more information. But in short words, what it does, it basically clears non-locked records from the client cache side, and also clears the whole current client's session cache. So you will be getting the data directly from the database. So if you run some of the calls multiple times, in the regular scenario, you will mostly get, in some cases, like cached results. So already what has been gathered from the database. So let's start with this first to clarify. So about NST caching. So benefit, basically, there is huge benefit of NST caching. So when you do redundant actions and repeating, pulling some data from the SQL, in a lot of cases you will get cached results. And it is important to keep the buffer not invalidated, and we will see in this webinar in further examples. When you invalidate the buffer, you will pull again the data. So let's move to the example, and we will analyze raw results versus cached results. So from the code side, we'll be using the same code. So for the NST cache, so we'll be going for 10 customers with some filter and just doing the FindSet, and that's it, 10 times. So in first case, so you can see that it is the same code, but in one case we are doing the database select latest version, in another not. So when we open that example, so let's open the chart first. And as you have made guess already, so with the NST cache, you get lots of performance increase. So the data is already gathered. You don't need to communicate directly again to a SQL server each time. But the first run, when you pull the data from the SQL, you will have it. So there is a huge difference in duration and in the SQL statements. So as you can see, when you are doing NST cache, there is only one call versus for NST no cache. Then for each loop, so 10 times, we'll be pulling each time freshly the data. So why is this important? Is that all further basically examples will be raw data, so non-cached results. So we can analyze pure performance. And same from number of SQL reads from the database. Okay, so with this being clarified, we'll move to our first example, which is using IsEmpty, then FindSet, versus just doing the FindSet only. And this has been like beginning of this year, like quite popular topic, and there was quite some noise. But yeah, so let's clarify what happens in the background. So in the background, Business Central, as I have already said at the beginning, from BC 25, I validated that BC platform does the optimization of the SQL automatically. So when you are doing the code, bad code even, so just FindSet multiple times, after a certain amount of repeating, it will optimize that SQL. We will see in further slides how. So store procedure is repeated, and after a certain amount of repetitions, it creates new one which is well optimized. In this case, it wraps it with if exists through whole FindSet query. And if you, in this case, put additional IsEmpty, then you have redundant call. So instead of using the optimized query which Business Central platform crafted, you will be getting double the IsEmpty. So let's first see in the example Visual Studio Code. So first we'll be again going through the customer table, setting the filter, then doing check if not is empty, then FindSet. And in the second example, we'll be doing just if customer FindSet, then some code. So in this case, without is empty, in first case with. And let's see what happens first. So in first case, when you have is empty, so you will be first executing the query which says select top one null, which is for is empty, and then the whole query for FindSet. So you will have those two queries, which is fully good. But after you repeat that number of times. After first call, then you will have like this procedure stored inside the stored procedure. So there is no optimization at this point. But if you run it like 3 more times, then you will see like the query where if exists is automatically being in front of the full FindSet. So just to have full picture, let's track the whole process. So first how it goes. So first you craft the FindSet on the first run, then that is in the stored procedure, and that's executed with the filter RS, for example. So second run, and then there is third run, all good. And on the fourth run, you see that Business Central platform doesn't use anymore the same stored procedure. So at this point, if exists is in front of whole FindSet, and now that is being stored as stored procedure 60, as you can see the number, and on the next run, the optimized one is being run. So you get 3 non-optimized runs. So, but afterwards, it will behave same as you would put IsEmpty in front. So if not IsEmpty, then FindSet. So it will be basically the same. And if you put IsEmpty in front, you will be just doing redundant things. So you will be bringing up one additional SQL query for something which is already being covered. So to have it graphically illustrated, so you will have IsEmpty communicating to the database itself, and then if it is empty is executed, then it moves to if exists, which is wrapped around the FindSet, and that query is also being communicated with SQL database. So at some point, it just becomes redundant. So this is the explanation, but let's see the performance side. So in Business Central, I prepared you some few examples with full table. In this case, IsEmpty and FindSet, and versus just FindSet without IsEmpty. And you can see that that there is a difference here. The IsEmpty and FindSet, when having large data set, is becoming slower. Also, the SQL statements, what I already said and mentioned, that when you are using IsEmpty, of course, there is one double query, which is run in front of FindSet, so it will be like double amount of queries. But if you use non-IsEmpty, then the platform will create fully new procedure which will contain that, and that will not be a separate query, it will be in the one. And the reads, again, the double or less. So this is with full table, which has a lot of benefit. But when you have the small table, again, there will be some benefits. In this case, a lot smaller, but still there is a benefit. And when you have always empty table, which is like the scenario where it's highly unlikely, but in that case, it's always exited at IsEmpty, so number of statements get equal, number of reads again equal, but duration in that case it's better to use IsEmpty. But this scenario is like 100% like that you are getting the empty table. So when that scenario changes, that you have like at least 10% times that you have the record, the results are not the same anymore. So of course this is the result when it is always empty, but the good pattern of what you should do is not using the IsEmpty in combination with FindSet. So that's from the practical side. Okay, so let's move forward to the next example. So SetLoadFields, it can be beneficial, so not to load all the data from the database and you to choose the data which you want to pull. It will be less heavy. But basically the use of SetLoadFields won't magically solve all your performance issues. It's like one step. It will in the logic and the code will benefit from, but it will not like be the magic solver if there is a real performance issue. So valuable pattern to gain performance, but it is just one step. So, and what it does, what I already said, it limits the number of loaded fields. So let's first check the Visual Studio Code, for example. So in this case, without SetLoadFields, we'll be going through all customers, checking the place of export if it is Great Britain, and adding it to the list of customers. In the second example, so we will be doing the same logic, checking the place of export, but we will be loading just the field which we need. So that's place of export. So one note also to add for SetLoadFields that even if you say place of export that you want to load, primary keys are always loaded, and also the system fields. So those two always get loaded. Okay, so that's from the example side. Let's analyze the query now. When you don't have the SetLoadFields, so we are just doing the FindSet, so it will look like that, the pull record. So it will have all the data containing everything. And if you have like multiple tables, then as you can see here, it has additional also joins from the table extensions and so on and so on. So it can become like a really heavy operation. But when you do the SetLoadFields, it will just load what you need. So in this case, we put place of export, and it loads drastically less of the fields. So here you can see primary keys, place of export, and then system fields, and number of reads and duration you see significantly like less, because it isn't that heavy operation anymore. And like I said, so this is one step of the optimization, but it needs to be followed with other steps. So from the example, let's open this chart. So we'll be like we saw in the example, going through the customers, and in one case just load place of export, in second not, and you see drastically the time difference. So it's much faster to load separately. In the terms of statements, it's the same. So in this case, the optimization is not in the number of the SQL calls, it is in the response itself. So whether it is heavy to the memory or not, in this case, as lightweight weight it is easier to process and return. So always when you can use like SetLoadFields, but it is like not, like I said, magic bullet which will solve everything. Okay, so let's move to the next example, and that's basically find minus or FindSet when having more than 50 records. So what's happening here? So with find minus, you are getting only 50 records. So you're doing like select top 50, and when you go to the top or the last record, which is 50 record, the next statement, when it is executed, it again triggers FindSet, but now it will pull all the rest of the data. So it will get one additional SQL query per call for each like 50 records. So if there is a larger data set, always use FindSet immediately, because you need to consider that find minus or find plus, it always runs, fills the buffer with 50 records. So you run find minus, the call is sent to the SQL database, it returns just 50 calls. When those 50 are returned and you parse it, you go to the last one, you execute the next, the new query needs to be crafted and sent. This happens everything in the background on the platform level itself, and now the full data set is returned. So you will be doubling basically the pulling the data from the database. So instead of having one SQL, you will have two SQLs per operation. And how is that looking in the SQL itself? So in this case, you can see the first pull from the database is only collecting 50 records. And then if there is a next and you need more than 50 records, there is new query crafted, and then that query starts basically from the last one till the end of the data set. So you pull first 50, then from 50 till the end, and that cuts basically the time to get the data. So yeah, here is just better comparison between those two queries. They can look alike, similar, very, but end basically different. So first just 50, and the second query starts in this case from vendor 9 till the end of the query. Okay, so let's move to the Visual Studio Code examples. So in first case, what we'll be doing, we'll be setting country region code for vendor, and we'll be doing find minus. So in this case, pulling 50 records, repeating, there can be some code in the middle, and when there is more than 50 records, in this case, the next statement pulls additional. You can do the same without it. So if you expect, in this case, to have more than 50 records, you use immediately FindSet. Okay, so how does that basically impact the performance? You can see that find minus has more execution time, but what we need to focus on is number of SQL statements. So number of SQL statements, as we can see, it's double, because as we already saw in the background what's happening, when you do the find minus and there is more than 50 records, you craft additional query and send it. And we always have, in this case, I run it with always having more than 50 records. So it is significantly better to use FindSet immediately. From the number of reads, it's the equal, but the statements matter in this case, because more statements, more time to process and everything. So it really matters to the performance. Let's move to the next example. And this one is like using CalcFields versus using AutoCalcFields. And this one gets missed a lot from what I see. So it basically does the same thing. It calculates the calculation fields, which have flow field formula. And so when you are using when you are using CalcFields, you are in the loop, for example, going, and for each of the loop, you're calculating some of the fields. For AutoCalcFields, you craft immediately when you are pulling whole data set, you immediately say to to do the calculation also in that query. We'll see in the next slides. But also you can use AutoCalcFields on the list page when you load the list page. When it is firstly opened on the page, you can define that, and then it will benefit the whole list, since it is in either case loaded, so it can be like that optimization. So let's first see from the code side. In first example, we are going through the vendors, and for the each loop we are doing CalcFields. So we are calculating, in this case, balance of the vendor and summing to the total balance. That's all good. But for the second example, so we are doing, again, filtering the vendor, but now instead of doing CalcFields in each loop, we are doing AutoCalcFields before the FindSet, and then it will automatically CalcField for a whole data set which is loaded, and we are again summing the total balance. So let's first analyze the queries here. Here we are doing the CalcFields one. So let's dig deeper one step further. So FindSet, then on the first CalcFields, that's the second step, you can see like select sum of the amount from detailed vendor ledger entries. So on the back end, there is store procedure basically prepared and run each time. So you see for each time, each vendor, it runs again and again the query. And this costs a lot. We will see in the analyzing of the performance. But what happens here? So FindSet, the data set is pulled, and for each record you do the CalcField, then communication with the database. And imagine like this, having like million of records, then it's pretty heavy operation, because in addition to the lot of the records, you are bringing one additional query. So what happens when you do AutoCalcFields? There is just one query, no more queries. So this is the FindSet query. And if you take a look on the second part of this query, you will see that there is, like, again, sub balance from detailed vendor ledger entries, some amount. So it is already preparing the calculation formula directly in this FindSet query. So it is not repeated anymore. So you get, instead of 1 million queries for 1 million records, you just get one, and that's it. So it's drastically improving just the way how you write the code. So putting it in front of FindSet drastically improves. So let's analyze the performance here. So duration, it's really a big difference. So 9 seconds, and in this case, number of statements like 25,500 versus 500 just the statements. So it's huge difference, and this is being run on 25,000 records. So it's huge difference to the SQL statements, and that's why the time is also big difference. From the read side, there is also significantly less reads. Okay, so let's move further. Calculating totals. So how do you calculate the totals in the loop versus CalcSum? So basically, what's the difference here is the place of the calculation, where the calculation happens. So in first example, when you are doing the loop calculation, the place calculation is basically Business Central itself platform. So, but when you are doing CalcSum, then the place of calculation is SQL Server. So there is huge difference there. Basically, moving to the different place of calculation makes big difference, and SQL is always performing better. So let's see the examples here in this case, which we will be running. So calculating totals in the loop. So we will be going through the vendor table, setting some filter, doing FindSet, and then summing budgeted amount. In the second example, we'll be doing again setting filter, then doing FindSet, but in the front we'll be doing wrong example. But in the front we'll be doing CalcSum. So in this case we don't need FindSet. We just do the CalcSum, and we assign that field to the total amount. So basically, you don't need also to load other data with the FindSet and everything. One also important note for all these examples is that we could basically combine different optimizations, like setting now the load fields and everything, but we are doing the pure performance comparison of everything. So each scenario separately. Of course, the greatest benefit is when you combine everything, all examples. Okay, so basically, let's go back to the presentation and check the query itself. So without CalcSum, you will be just pulling all the data, so with all the fields and everything, then reading through it and then summing the fields. So that costs performance. But when you are doing the CalcSum, then you will be telling basically to the SQL to calculate you that field automatically with what filters you need. So place of calculation in this case matters. So let's take a look on the example itself. So we'll be doing also one additional example with SetLoadFields, which I already mentioned. But in this case, yeah, we have it combined. But the point is not to have everything combined and to compare the pure results. This was just from the attendance feedback that we should test that, and I added it to examples. So in this case, calculate totals in the loop takes the most. Then still, when you have SetLoadFields, it takes more than CalcSums with place of calculation on the SQL, but still not good as on the SQL. Of course, much better than having not set any SetLoadFields, as we already covered in the previous examples. So from the number of statements, everything is basically the same. In the first two examples, it is FindSet, which is more heavy operation, than to the third, which is basically some query for the SQL. Okay, so let's move forward. If not insert, then modify is the next example, and why it's bad pattern basically. So this is like when you want to insert something, but then you see, okay, that record is already existing in the database. Let's just modify it. So there is basically a better way, because this one is also preventing all the buffered inserts, and each time, and this is why it is slower, each time SQL error is basically raised and sent to the Business Central. So each time it is raised, then Business Central platform needs to parse that error, and then after everything, only then it moves forward. So it is much slower and less efficient due to SQL error handling between the platform itself and the SQL itself. So, but this pattern can still be used, and when you have the singleton table. So what happens graphically visualized? So you do the insert, you send a call to the SQL, then error is returned, you press the platform process the error, and then you need to craft additional query for the modify, send it to the SQL database, and return it. And only then that's successful operation. So a lot of processes. So when we take a look this process, we think like, is there more efficient way? And there is. So let's see it in the code. So open Visual Studio. So in the first example, we'll be doing some customer, which is already existing in the database, and saying if not insert, then modify. But in the second one, we are using IsEmpty, then insert, else like get, then modify. So this can be also differently structured. You can immediately use customer get and then determine the correct operation, because even if there is no customer with that primary keys, get is like a really fast operation, and no error, SQL error is raised, and that makes the difference basically. So putting either in either pattern, so either IsEmpty or just customer, if not get, then insert, that's still much better way than doing if not is insert, then modify. What happens on the SQL level itself? So in first query, the insert is crafted. So as we said, that one is sent to the SQL database, error is returned, so you need to prepare additional query. But when you are using more optimized approach, it's a lot different. So you select, for example, when you are using IsEmpty, you are doing like select top one null, so determining what is the correct operation. So IsEmpty is like really fast operation compared to failed insert, which need to raise also the error. And then the second query is basically, in this case, modify query. So it is determining the correct operation, doing the correct one instead of returning the error. How does that affect the performance? The duration is much better when using the correct operation and determining with IsEmpty the correct operation. From the SQL statements, in this case, we have like two statements at least for each. So either one statement for checking the correct operation, or in second case, the incorrect insert operation. From the reads, you can even get more reads when using the get statement, but get statement is well optimized, and you can sacrifice the reads more than incorrect operation. Okay, so let's move forward. So the next example is using the count equals 0 versus IsEmpty, and on first site it can look like it's the same, but it is not. So in first case, you are selecting top one, but when you're doing the count, you are counting the whole data set, which needs some processing time for the SQL to return the number. And on the small tables, does it really matter? No. So if you are using if there is some small table, if you don't use IsEmpty instead of count 0 or vice versa, it will not matter that much. So let's see first the code part. So count 0, so we'll be using vendor count 0, and then second vendor IsEmpty. Simple as that. So, but what happens in the SQL? So as said, so when using the count, we are just getting the full count on the table. And again, if it is a small table, then it's fine. But when you have like big table, it matters. And in the second query, we are using with IsEmpty select top one null, and just checking, not pulling any data, not getting all on the count number or anything. So we are just checking if there is at least one record in the database. Okay, and from the performance side, when we do count 0 versus IsEmpty, you see the count 0 is performing worse. From the SQL statements, it's same. And what matters here is which SQL statement is performed. So either it is one heavier statement or less heavier, which is more performance-wise and easier to process. So let's move to the next examples. Temporary tables, and this one is I think obvious to a lot of you. And so when using the temporary tables, there are no SQL queries exchanged. So it's for some certain scenarios better, and read happens almost instantly. But when doing the temporary tables, there is also the way how we define the temporary table also matters, and which in this example we will see. So it's not same. So let's open Visual Studio. So first we will have like regular table. So inserting, then FindSet, and then deleting all. In the second example, we'll be using whole regular table, but just defining that as variable temporary. So that will be still temporary table. And in the third case, we'll be creating full temporary table in the background and using that one. So here we will see what is basically the difference between each of the scenarios. So let's first cover the durations and the SQL queries. So as you can see here, the normal table, of course, takes the most time. But what we want also to analyze is using the normal table as temporary, as in variable, versus declaring it fully as temporary table. And as you can see, like full temporary table, of course, is much better. But in some cases, yeah, you won't be creating for everything like just the temporary table object, but of course declaring as temporary variable of the table. From the SQL statements, there is only for the normal table SQL statements. So there are no SQL reads, inserts, or anything for temporary tables. What happens in the background itself? So when using the temporary tables, the queries for the operations and of the examples which we covered are crafted. But when using the temporary tables, I selected all the whatever we collected, so you cannot see any operation that is being exchanged between Business Central and the SQL server. Okay, with that being covered, let's move to the next example. FindFirst, then looping through everything. And again, we will be invalidating the buffer itself, like we did with find minus, with filling the buffer with only 50 records. We will be now filling it with just one. So this is the queries, top one, and on the next we need to refill the buffer. Let's cover the same slide, just visually more friendly. So FindFirst, we point to the SQL, return just one record, and we can still do the next, but this will be like really heavy operation, and we need to fill again the full data sets again from the database. So this costs a lot of the time. So when we analyze the query, so we are doing the select top one, pulling the data, but when we do the next statement, it again executes the same the FindSet. And in this case, like we saw on the find minus, this second query is starting from the first vendor we have done with FindFirst. So from that one till the end of the data set. So from the example side, we'll be seeing like FindFirst from the vendor, pulling just one record, some code, and when there is more records, it needs to fill again. With find minus, I just put it for comparison. We covered that already, but we'll be getting only 50 records, and with FindSet, we'll be pulling all the data. So how does that look like in the chart? And you can see like the FindSet is in this case not performing the best, but I used only certain number of records here, so 69 records. But when you have the data, it's much less heavy operation for the database to return just immediately the whole data set. So let's move forward to the next example. So changing filter inside the loop, and similar to getting the wrong size of the data set to your side, it is similar to that example. So you are again invalidating the record buffer which you are storing temporarily, and with this being invalidated, you will be needing to send a new query to refresh the buffer again. So when you load first 50 records, for example, with FindSet loads already, then you change, for example, the filter, and then on the next it gets invalidated. So let's first check from the code side what is meant by that. So vendor is having some filter, it's FindSet, okay, and then it's checking some condition, and if that condition is true, then the filter is invalidated. So basically here we are setting the shipment method code, but the second one, which has more correct approach, would be to either fill dictionary or temporary variable with those vendors which need to be changing the filter, and then you can filter those new ones with second filter. Otherwise, you will be invalidating the buffer which you already filled immediately after next statement. So when this condition is fulfilled and this filter applied, when you execute next, it will need to craft additional query. So here, as you can see, FindSet is firstly getting correct filters and everything, the whole query, but as the condition is fulfilled, it needs to execute it again with different filters. So that basically invalidates the buffer and needs to refill it again. This is heavy operation and needs time for processing. So changing filters, how does that impact the performance. It's like regular loop, filling even the temporary table. It's more or less operations for the database. So even the SQL statements are one less. But if you repeat this operation more often, you can get more performance downsides. Okay, so let's move to the next example, which is IsEmpty before FindSet, or FindSet before DeleteAll. Sorry. So we covered already that IsEmpty is covered through the FindSet, but even when doing DeleteAll, IsEmpty is also being covered. So in the query, it's already being contained. But there is one downside. When the table is already empty, it can have certain locks, which we will see in the further explanations. So let's do DeleteAll only and catch that query. So it already checks row count if it is different than 0. So it won't perform that operation on the already empty table, but it happens a lock behavior. So in order to avoid that, you will be doing IsEmpty, which is less heavy operation than DeleteAll, and you will basically avoid lock behavior. So from the code side, we'll be doing 3 examples here. One is empty before DeleteAll, so we'll be checking is empty, then deleting all, then performing insert, just to make sure we didn't lock the table. In second example, we'll be doing FindSet, which will basically be successful, but we are pulling the data we don't need. So we fill the buffer, which we don't need. Then we insert. And in the third example, we are doing just DeleteAll and then insert. So those 3 examples, basically, and the fastest one is only DeleteAll, but at what cost? So when you do it on the empty table, it will get locked. But if it is not empty and you are certain about that, yeah, you can use DeleteAll only, but there is a cost, and you cannot guarantee that it is always not gonna lock the whole table. So the same basically example, but when there is a lock, so DeleteAll, then insert. So when doing IsEmpty in front of the DeleteAll, that operation is actually getting more performance. So it depends on the scenario, but DeleteAll basically comes with the cost. So with the locking behavior, it can basically cost you more. Let's move to the last example for this webinar, which is how you would basically determine whether there is only one record in the table when there is a large data set. So this one is a really big one and can really affect the performance. So on the large data set, of course, if it is just a small table, you just don't need to worry about it, and that's all fine. So we are speaking about the large data set. So with FindFirst, you can avoid count 1, which needs to count all the records from the data set. But FindFirst will select just one, and then with the next, you can see if the next top 50 are loaded. But with the find minus, it's the correct solution, because you will already load 50 records if they are existing. And then with the next, you can see if we move to the next record without additional query crafting for the top 50 on the top of the FindFirst. So let's first check the code. Count 1, So the customer table which we are having does have like 1 million records. We are doing the count, checking if it is there just one record. On the second example, we are doing FindFirst, which will load just one record, but with the next, it will craft additional query for additional 50 records, and then it will check like if that is possible to move to the next record. And the most optimized the query, how you should work on that large data set, finding just the one, if there is one record, is doing the find minus, so filling the 50 records, and then doing the next. So if that is true, it will say that it has only one record. So from the performance side, let's load that one. And you can see like the count takes the most, but find first with the next or find minus with the next are much better. But basically the main difference between those two are number of statements. So in this case, 2 statements are executed for the find first and next, and 1 for find minus and next. So let's just check the queries. So count, most heavy operation on data, large data set, which we are having. Then find first. So we are selecting top one, but with the next we are crafting additional query. So the second find set, and the last one we're doing find minus is just having one query, and that is the optimized one. So we will be doing find minus, then selecting 50 records. That record is being selected. On the next, it will determine whether you can move to the next or not, if there is a next, basically, or not. But the buffer, internal buffer, is already being filled. So that will be it. But you can go join us on official AL guidelines, and this is the official one from the Microsoft, but initially crafted by Henrik, Waldo, AJ, and Jeremy. And this is really beneficial in this time also when we have the AI and everything. So the plan is basically to have the full library of good patterns, which we can use for also for training of developers, also training the AIs and everything. That will be it. Thank you very much.
Thank you, Stefan. We do have 2 questions. If I can quickly answer, we're a bit short on time, but hopefully Luke won't get upset at us going over the hour. We'll push it anyway. The first one is both from Peter Konyin. The first one is about SetLoadFields. I think it's also an important one. Just to mention that obviously if you're using SetLoadFields and you do an update or later on, then it's going to reread the table. So you need to be careful that SetLoadFields is only used when you're purely reading. So I think you just wanted to mention that.
Okay, I'm just reading it also. Mm-hmm. Yeah, that's one of the scenarios which you need to be careful about when it will be doing the JIT loading.
Great. And the second question is about read isolation hint. I think the question really is it something you can cover in this presentation or a blog post, or he's got more information?
Yeah.
You see the question?
Yeah. So in this all examples, we didn't cover like read isolation, and it can basically change the behavior of some examples, but this is like changing the story fully. So in combination with read isolation, you can basically get even better results, or for some of the results patterns already shown, you can get worse results. But the point was not to cover the combination of read isolations inside this.
Yeah, okay. I hope, Peter, hoping they answered your question. Yeah, so I just thank you very much to Stefan for this presentation. It's been actually really good to see, for people just to see the SQL query that they're creating when they do the Navision. So just to close up, I wanted to say thank you to our sponsor, FORNAV. Michael, I see you're in the session here. Thanks for joining us and thanks for supporting us. It does look like it was my microphone. I thought your microphone unplugged again, like we had at the beginning of the session, but people are saying they could hear you, so actually it was me this time. So sorry about interrupting your session. We'll hopefully edit that out later. So thank you very much to everybody that's joined here and come to our session today. We do have quite a few. Remember to just a reminder, go to Areopa Academy to find out what's coming up next. And again, if you want to have a go at talking, please let us know. So thank you, everybody. That's it. And goodbye. Thank you. Good night. Good morning. Whatever the start of your day, end of your day. I'm off to bed. And thank you very much.